Hey guys, welcome to another episode of Black Guy Does Physics. Where, hey, I guess a black guy does some physics. Today we have the lovely Miss Sienna as our assistant. Say something.
Hi.
Hi. Well, yeah, she'll be helping us today solving this. I think this is a ladder problem or something. Yeah, but that's what we'll be doing. The app that I'm using is Notability, and it's an awesome app. The reason why it's an awesome app is because there's so many things that you could do with it. I don't get paid for saying about it, so I don't have a link or something. But it's good, man. It's good for note taking. It's not that expensive. It's crispy. It's clean. It's great. Check it out. Okay. All right. With that being said, let's get it cracking. Now, why Miss Sienna is here? She's presently in my class, and I'm trying as we work this out. If she has any issues or questions or something, she could ask, so it could help you all when you're doing this, okay? So we're gonna look at a question. First thing we always want to do is that we want to look at the diagram itself. So when I look at the diagram, I see something resting on a wall, and I think this is a floor. So automatically I see that this thing isn't moving. Mm-hmm. So if this thing isn't moving, the type of problem that it is a static equilibrium problem. So I just write that down just because. Just that. So as I read, what I do is that I read and underline what I have. So it says a uniform ladder. So it's a ladder, and it's a, let me change it to like a pink or something. It's a mass M. So I put, ooh, no. That's not gonna work. That doesn't look good for me. So M, right? M is M. So I put a check mark because I know M. The length of the ladder is L. So I put L is L. I know L. And the angle is theta. So theta, I do know it's theta. Notice they're not giving you any numbers. It's just all variables. Mm-hmm. Kids, and I'm pretty sure yourself, are afraid of variables a lot of time because you're like, what the hell is letters doing in math? Or nah, bruh. Variables are your friend because with variables, you don't have to use a calculator. You set the thing up. The only problem with math is when people start using calculators and they actually have to calculate things. Usually, if you don't have to calculate, what we're doing here is that we're not really calculating things. We're just putting things down. Right, Shadrach?
Yes, sir.
Yes. So we're saying, okay, so we have theta and it's against a frictionless wall. So the wall has no friction. So I can put that if I want. Right? And the ladder and the ground, the coefficient of static friction is mu s between the ground. So here we have some friction. And it tells us the static means it's not slipping. So that's mu s. So I know mu s is mu s. And I want to figure out the minimum angle at which a ladder does not slip. So I'm trying to figure out actually theta. So let me erase this because they're asking you, what is theta? And they're saying theta minimum. Do I care that they're asking about theta minimum? No. Because I just want to know what angle this thing is at right now where it's not slipping. So the instructions for the static equilibrium problem, because it's a static equilibrium problem, we know that there are two conditions. Condition one is that the forces up is equal to the forces down, the forces left is equal to the forces right, which is F net is equal to 0. Condition two is that the torque net is equal to 0, which means that the counterclockwise torque is equal to the clockwise torque. And you could write those down if you want. If you want to write those down, you can, just so that you don't forget. So I'll write them down just so that we remember. So we're saying F net is equal to 0 and torque net is equal to 0. We know that this is true all day, every day. But in order to do this, in order to actually calculate the thing, you have to draw all the forces that are acting under. So remember, we have, how many forces do we know? 5 forces, right? Mm-hmm. Weight, friction, tension, spring, and what's the other one? What are we missing? Crap. Weight, friction, tension, spring. What's the other force?
Weight, tension.
Yeah, think we said whatever it is. We're missing it. I can't remember it right now. Normal force. Normal force. There we go. Sweet. Normal force. So we have those 5 forces. So we're gonna check. So this is a ladder. So whenever you're doing a static equilibrium problem, you have to look at the forces acting on the object that could rotate. So this is the ladder. So we're gonna look to see where the force is acting. So for a uniform beam or uniform anything, there is the weight of the object will be acting in the center of the object. Do you want pink arrows or red arrows for the forces?
I believe red arrows.
Red arrows? All right, let's go. Let's keep it red.
Is that why you switched?
So, that is. Oh, hear my background music? That's red arrows for. That's red arrows for. That would be the weight of the object right there in the middle.
Yeah.
It's touching a wall, right?
Mhm.
So this would have some normal force, and the normal force is always perpendicular away from the surface. So this is like this, and that should be perpendicular. Then there's some forces here. Remember, on the wall is frictionless, so there's no friction. Here, there's some forces. There's one force here, which is the normal force. And if this thing is going to slide, it's going to slide backward. It's going to slide like this.
Mhm.
So the friction should be acting this way, parallel to the surface.
Exactly.
So now we just label them. So we're going to call this Fn, and call this Fn1, and call this Ff. Sweet. Oh, Mg. Nice and easy. Not too much. So now we're going to check. When you're doing one of these static equilibrium problems, if they're not really asking you for some sort of force or whatever, you don't start with forces up equals forces down. The reason why you don't start with that is because you're always going to have two forces missing. So if you have two forces missing in each dimension, it's a wrap. In other words, you just start with torque. Always start with torque, just because. So because you're starting with a torque now, in order for you to do a torque problem, you need an axis of rotation. So the trick is you just pick somewhere where there is an unknown force. So we know Mg. Go ahead. Go ahead. Yeah, man. Which one? This one at the bottom here?
Yeah.
So let's check it out. We don't know Fn1, right?
Mhm.
And we don't know Ff, yes?
Mhm.
And we don't know Fn. So it's either here, you're right, or here. If I pick here, what's going to happen is that this, I'm going to create a torque using this and this.
Mhm.
So I could solve for what Fn is.
Okay.
But that's not going to solve for
the
the
main
angle
problem.
here, probably. But if I pick here, I'm going to have a problem because these two things are going to be creating torques.
Mhm.
And that's a problem. So the smart bet would to be here. You see? Because I don't know three things. I don't know this, or this. But even though I know F is mu Fn, we'll get into that in a minute. So let's pick where you said. Good job. Let's pick that. So let's pick here because they're unknown forces. There are more unknown forces here. So once you pick there, then what you have to do now is you have to bust these forces up parallel and perpendicular to the rod. So it has to be to the rod. It can't be to some axis that you created because you're looking for the perpendicular part of the force to the rod. So this is the rod here, as you can see the big black rod there, and this one isn't parallel or perpendicular. This one isn't parallel or perpendicular. So I have to bust them down into triangles. These two, I don't bust down at all. I don't touch them because they're at the axis of rotation.
Exactly.
So if they're at the axis of rotation, they create no torque. Remember, this crap isn't really rotating. I'm just saying, yo, if it was or I wanted to, I could put it there. So let's bust these down into their, so I bust one down like this. And I put one like this. Then I bust one like this. And I put one like this. And then the quick math. Quick math is if this is theta, then this one has to be theta. Let's put it in red. And this one has to be theta. See? I know you probably should understand it. If you don't understand it, it's very simple. This one, you just keep it. It's bottom.
Okay.
That's it. Bottom. Up here, this one has to be theta. Very simple. Z. Once you create a Z like this, right? These two angles are the same.
Oh, it's kind of like geometry.
Yes, it is geometry. It's opposite interior angle, some fancy name. I just call it Z, bro. It'd be alright. It's just Z. So then we label this junk. Let's go with our finer tip. Then we label these junks. This would be, because it touches the angle, this would be my cosine. This would be my sine. This would be my sine.
18 because
This would be my cosine.
halfway through perpendicular.
Sweet.
Mm-hmm.
So now, what the kids, especially in your class, all of them, what they're forgetting is this very important step. They're forgetting that the torque of something, what the actual torque is. The torque of something is R times F perpendicular, or R perpendicular F. So if you're going to use the torque net, you have to use this equation. What it literally is saying is that R is the distance from the axis to the force, and then F perpendicular is the perpendicular part of the force. So this part would be from here to here, that's R, times this part.
Oh, okay.
And then this one would be from here to here, that would be your R, times this part.
Oh, okay.
That's it. That's all you have to do. Yeah. So, I give another thing where I said you should try and figure out what type of torques these things are going to create. So Fn would create a counterclockwise. The reason why it's counterclockwise is that if you push Fn, I know what I'm doing, you can't see my hands right now, but she's seen my hand. If you push Fn, it would cause the whole thing to turn that way, yes?
Yes.
If you pull mg, it would cause the whole thing to turn this way.
Yeah.
So this would be your clockwise.
Oh, okay. That makes
You see? That's it. So now what does torque net means? It simply means torque net is equal to 0. What it means is this. The torque, the sum of the torques clockwise is equal to the sum of the torques counterclockwise. So it simply means I'm going to add up all the torques that are causing clockwise. In this case, how many forces are causing clockwise torque?
just one.
Just one. So I need the torque of that. I need the torque of mg. And also it's just one for that, right?
Yeah.
I just need a torque of Fn. That's it.
Mm-hmm.
Then all I do is just use this equation over here. The torque is equal to Rf. From here to here, from here to here, since it's in the middle of the rod, that would be half a L,
Okay.
right? So my R for that one would be half L, or L over 2. And then for my F perpendicular, it would be mg cosine theta.
That makes sense. Yeah.
And then this one, you repeat the same procedure.
Okay.
From here to here would be L,
Okay.
and then, so it would be L, and then my force, my perpendicular force would be Fn
Yeah.
sine theta.
Mm-hmm.
Oh, that's hideous. I should, that looks like. So now we're looking for theta, right? So we check. Remember the famous check. Students don't like to check. So we don't know Fn, right? We don't know, we know M, but L's cancel. Do you see that L's cancel?
Yeah.
Okay, the L's cancel. So this cancels. So we don't know Fn. So in order to find theta, I need Fn.
Okay.
So that's a problem. So in order to find Fn, I have to go to the other condition, which is F net is equal to 0. So I should have dropped this here. Should have did this. F net is equal to 0. Hey, look how dope this thing is, everybody. Let me show you what it could do. Hopefully I don't do something crazy. Okay, let's do it. Watch this. Oh, look at that. So smooth. And I messed this up, I could just take that and move it back there. Notability, I tell you, it's the truth. Alright, cool. Let's go back now. So we're gonna, that's not F net, sorry. This is torque net. And this is F net equals to 0. So now, when I look at this thing, right? When I look at this, I see two forces acting vertically.
Yes.
So I see one going like this, and I see one going like this, and I see one going like this, and I see one like going like this. So what I do now to make my life easier is that I switch my axis of not axis of rotation, my x and my y axis. It would make sense if I drew my x and my y axis like this, would it not? So this is my y, this is my x. The reason why is because all the forces are acting vertical to the page and horizontal to the page. So now when I do F net is equal to 0, I don't have to bust nothing down.
Exactly. You
So I'm
wouldn't have
saying?
to replace the word.
Yeah, you don't have to do anything crazy. So if you look at F net is equal to 0, it simply means that the forces up, the sum of the forces up is equal to the sum of the
Hey, Mrs.
forces,
Smith, it's 220.
forces down. And I know I'm doing a video right. I'm doing a video right now. Everybody have a wonderful weekend. You're messing up my video. Bye.
My apology.
Bye.
Wonderful.
Have a good one, Smith.
All right. Sorry about that, everybody. Let's go. We're almost done. So we have 1 second. We have here. It's the forces up is equal to the forces down, and the forces left is equal to the forces right. So let's look at the forces up and the forces down. Which force is up?
Definitely. What was it? Definitely that one.
So it's Fn1 is up and Mg is down. Sweet. So we could check. Bye. So we could check again. We could check again, and I definitely don't know Fn1, and I know M and I know G. So I'm good. So now I know what Fn1 is.
Exactly.
It's M and G. Sweet. Then, that's good. So let's go and see if I know. Let's go and look at this. The forces left is equal to the forces right. So what are the forces left?
What was it? Definitely FN?
Fn, yeah, man. So it's Fn. So Fn is left, and I think Ff, the frictional forces,
Is right.
is right. So automatically, remember we were missing the friction Fn, right?
Mm-hmm.
And that's what we're really looking for.
Yeah.
But now we don't know Ff. But do you remember the equation for Ff, for frictional force?
I'm not completely sure to be honest.
No problem. No, you always should be honest. So let's get it. Ff, whenever you see this, you could rewrite it as this, mu Fn.
And that's what FN will be equal to.
Hey, look at you, look at you. So now, because you see Fn, this is Fn1, sorry, yes.
Mhm.
So if you have Fn1, now you're going to substitute that in there.
Okay.
So you're going to see that Fn is equals to mu, what's that? Mg.
Oh.
Because Fn1 is
Is
Mg.
equal to MG.
Yeah, so you're going to
Okay.
substitute that in.
Alright.
So Fn is equal to mu F Mg. So now, because you know this, you could take this stuff and substitute it back all the way up here.
Okay.
So when you substitute that back up there, you end up with, let's see what we have. We had got rid of the L's, right?
Yeah.
We end up, let me write substituting. Even though I said it, but let me write it. Substitute Fn into first equation. And then we could see here, we could see here that that would give me Mg cosine theta over 2 is equals to, what's Fn?
Oh,
Mu
mu MG over well, no, just
sine
sine.
theta. So, sweet! So now, I could cancel out the m's, right?
Mm-hmm.
So my m's go away. Let me make a finer point. So my m's go away. And then I could divide through by cosine theta. So I'll have this stuff over here. Oh, my g's go away too. We missed the g's.
Yeah, I was about
My
to say
bad.
I wasn't sure.
Yeah, you could have told me, man. Oh, my g's go away. Sometimes I'm a moo man. It works. Yeah. It is what it is. So my g's go away. So I'll end up with sine theta over cosine theta, which we all know what that is, over 1 over 2 mu. So that would give me tan theta 1 over 2 mu. Then if I want to find theta, I take the tan inverse of both sides. So theta should be equal to the tan inverse of 1 over 2 mu. And that's it.
That's the answer for the.
Yes, that's it.
I
So,
actually understood that.
I know. It's because you're sitting here. So that's why you should watch the Black Guy Does videos. And you should make comments like everyone else. Hey guys, we're done. And she understand. Look at that. As I said, we're doing magic. So now, remember, what you should do is smash the like button. Subscribe if you want some more of this action. Okay, everybody? All right. And the last thing, as always, kids, don't be a moo-moo.